Thank you. Hi, can everybody hear me? Cool. So yeah, I'm very excited to be here and to talk about this project. I thought that as I'll be speaking about young children's abilities to make adaptive information search decisions, I was going to invite you to make an information search decision yourself. So option A is you can continue listening to my talk, and I promise that I'll provide you with empirical evidence that preschoolers can differentiate between relevant and irrelevant information. And I'll provide you with some preliminary empirical evidence that even infants are sensitive to the informativeness of different cues. Or you can zoom out and watch kitty videos on YouTube. Now, the reason why I picked this example is not because I like cats so much. I do. But because I hope we can all agree that in the digital world where we are flooded with information, being able to make decisions about what is relevant and what is irrelevant content is very crucial. But how does such an ability develop? So we know from the research that children, when they are presented with information board games, they struggle to select the most informative options. And we also know that they often have difficulties asking informative questions or selecting informative questions. But at the same time, we also know that when presented with selective trust paradigms, children are actually quite sophisticated when it comes to selecting the more knowledgeable or the informant based on the expertise that they have. And we also know that when presented with child-friendly paradigms, children adapt their information search to different goals and different structures of tasks. So to reconcile these somewhat contradictory findings, we designed a study with 2 experiments containing 2 child-friendly paradigms, and we tested preschoolers and infants. And the first experiment was a joint project with my former colleague Nora Swaboda and my supervisor Azzurra Ruggeri, who's a professor at the Central European University in Vienna and at the Technical University in Munich. And in the study we asked, can preschoolers select the most informative option between 3 options that allows them to disambiguate the location of a hidden present? And to address this question, we created an adaptation of the finding presence design that was published in 2021 by Lindo. So she presented children with 4 boxes and 4 information cards, and she found that 80% of the 5-year-olds can select a relevant information card that allows them to find a hidden target in one of the boxes. And since we made a simpler version of the game, we addressed 2 to 4-year-old children, and we tested them in the Berlin Zoo and at the Max Planck Institute in Berlin. All children went through a practice phase, and then they entered 2 generalization tasks. So what was the practice phase like? We showed children 3 boxes, and in one of the boxes we hid a sticker and we told them that they have to find it. Let's assume that we hide it in this box. This is just an example, so we also had a counterbalance version where we, oh sorry, that was too fast. So as you might notice, the boxes all share 2 features, so they are all red and they are all hexagons, but they differ in terms of the icon on top of them, right? But this is just an example, so we have a counterbalance version where the differentiating feature are the shapes of the boxes or the colors of the boxes. Okay, so let's come back to our initial example. Red hexagon boxes with different icons on top of them, and we told children they have to find a sticker. And then we gave them 3 information cards. 1 information card told them the shape of the target box. 1 information card told them the icon on top of the target box, and 1 information card told them the color of the target box. And in this example, the only informative card is the one that tells them the icon on top of the target box, because it's the only information that allows them to disambiguate the location of the hidden present. So once children passed this practice phase, they entered the generalization task 1. And here we presented them with the same 3 boxes, but with we hid the sticker in a new location. So for example here, and then we presented them with the same 3 information cards, and we asked them which one they want to flip. And again, the only informative information card is the one with the sticker, because it is the only one that allows to disambiguate the location of the target sticker. Okay. And what we measured was whether children, which card children select, and children have had up to 2 attempts to select the card. Here's what we find. So this graph shows you the percentage of children who either fail, need 2 attempts or 1 attempt to select the right card on the y-axis, and the x-axis shows children binned by age in years. And there's going to be a red dotted line indicating the chance level. So what we find is that all age groups perform significantly above chance when it comes to selecting the correct information card. So now some of you might say, well, Daniil, you promised us that you will provide us with evidence that children make adaptive information choices. Why? Maybe children are just copy-pasting what they did in the practice phase, right? So to address this possibility, the same children entered the second generalization task, where we presented them with 3 new boxes, and we hit a sticker in one of the boxes, and we presented them with 3 information cards. And in this example, the only information card that makes sense to flip would be the shape information card, because it's the only card that allows to disambiguate the location of the hidden present. And what we find, so here's again similar bar plot, so percentage of children who either failed, needed 2 attempts or 1 attempt on the y-axis, and children binned by age in years on the x-axis. And we find that even 2-year-olds are performing significantly above chance, and 4-year-olds are performing at ceiling. So that was very surprising to us, because the large majority of empirical evidence suggests that children should not be able to perform such a task until around the end of preschool age. However, since we were so successful at finding that even 2-year-olds can do it, we thought we could address an even younger age sample. And we were optimistic to find that even infants can do a similar task or show at least sensitivity to the informativeness of different cues because of the literature that suggests or that highlights the competencies that they have. So for example, we know that infants are sensitive to the different probabilities of samples and how samples are generated. We know that infants take into account the knowledge of potential informants when they search for information in their pointing gestures. And so experiment 2 was a joint project with my colleague Yi-Lin and again my supervisor Azzurra Ruggeri. But I also want to mention that we got very helpful support by Francesco Poli and Tommaso Ghilardi. They helped us with the design, so thanks very much for that. And here we asked, are infants sensitive to the different informativeness of different cues? To address this question, we designed an eye tracking study, which we tested in the lab. And the design was a within subject study. There was no familiarization or training, but children kind of just started with the procedure. And then once they disengaged with the task, the experiment ended. We pseudo-randomized the order of trials that we presented to children, and all children sat on the lap of their parents, with their parents wearing dark glasses to not confound the measurement of the eye tracking. We used very minimal verbal instructions, just things like, where is the animal? And, oh, there it is. And so we tested 48 children between 13 and 20 months of age. For the eye tracking, we used the Tobii device, and we measured infants' looking time and pupil dilation. So perhaps a word on pupil dilation. We know that looking time and pupil dilation serves as a measure for different cognitive mechanisms. But recently, or not only recently, but it has been suggested that pupil dilation can also be an indicator for expected information gain. And this is exactly what we are going to be looking at in our study, along with looking time. And I also want to mention that we know that luminance can impact the measurement of pupil. So we kept all the stimuli in the same luminance, but the stimuli I'm going to present are slightly altered for reasons of visibility. All right. So what did the procedure look like? We tried to mirror the idea that we had before. So we presented children with 4 boxes that differed in either shape or pattern on top of them. So here you see 4 triangles with different patterns on top of them, or children saw 4 different shapes with the same pattern on top of them. Now, importantly, we presented children with information cue cards. So here, the shape information card, when it flips, reveals the shape of the target where reward is hiding. And the pattern information card, when it flips, reveals the pattern on top of the box where the reward is hiding. And now, depending on the configuration of the box's shape, or the box's patterns and information cards, one of them is informative and one of them is uninformative. I'm going to explain this with an example, okay? So here, for example, is the shape information card. A shape information card flips in an animation, and children can disambiguate the location of the hidden present or the reward. Whereas in the pattern information card, when it flips, children cannot disambiguate the location of the hidden toy. So that resulted in some trials being informative and some trials being uninformative. I'll give you an example of a full trial of a full informative trial. So children see the 4 boxes and the 2 information cards for 5 seconds. Then the 2 cards merge. They see a fixation cross for between 1.5 to 3 seconds. They see the back of the informative information card, so in our case, the shape information card. In an animation, the card flips, and it reveals the target box's shape. Then they see the color changes briefly, and they see the reward. So this procedure took about 20 to 22 seconds, and the same is true for the uninformative trial, but here children saw the pattern information card from the back. Then the card flipped, it revealed the pattern on top of the box, and then the target box color changed, and then they saw the reward. So I want to mention that these 3 time windows are especially relevant for this, or maybe I should also say that on average children performed 16 of those trials, right? So they went through all of them 16 times, and some of them were informative, some of them were uninformative. And these particular 3 time windows would allow children to make an association between the back of the card and the front of the card and whether the card is informative or uninformative. And we should see this especially in those 2 time windows here, which are also the time windows that I'm going to be focusing on in my presentation, or like in the rest of the talk. So let's begin with this. So here we predicted that children should be looking at the informative card when presented with the 2 information cards and the 4 boxes in the corners. So in this example, it's the left card because this is the shape information card, which will later allow them to disambiguate the location of the target. And we measured children's preferential or looking time at each of the targets. So this graph shows you the average time that children look at each card in seconds. Children's age in months is on the x-axis, and the 2 cards or the 2 conditions are in different colors. And what we find is that, in fact, children look significantly longer at the informative information cue card, and that there's no interaction with age. Next, we looked at children's pupil dilation at this time window, and we predicted that when they are presented with the back of the informative information card, we should find an increased pupil dilation because children can expect to get informative information and be able to disambiguate the location of the target. So this graph shows the pupil change in millimeters on the y-axis. So if there was no change at all, you should see a horizontal line. The 2 conditions will be in different colors. And the x-axis shows the 2 time windows. So there is the fixation cross. I've put this in because we are using the last 500 milliseconds of the fixation cross as a baseline. And then the 3,000 milliseconds that children see the back of the card are also depicted. And we find a significant increase in pupil dilation in the informative condition. So that suggests that infants are indeed expecting that to get relevant information after the card flips. Okay, so I'm going to wrap this up. I have presented 2 paradigms to study young children's ability to make adaptive information search decisions, and I presented also a paradigm that allows us to study the sensitivity of infants for the informativeness of different cues. I presented you some evidence that even 2-year-olds can differentiate between informative and uninformative information, and that disability improves with age. And I also presented you some preliminary evidence that even infants are sensitive to the informativeness of different cues. Thank you.
Thank you very much, Daniil. Questions?
Hi, thank you for a great talk. I was just wondering whether you, this in the infant design, whether you see also this response and anticipation, for instance. Do they use it actually to then guide their behavior and orient faster to the cue that was?
In which time window do you mean?
After the cue is revealed.
Oh, okay. We haven't looked at this, but it's a good idea, yeah. Thank you.
So I'm not sure whether I understood correctly, but so how did they learn about, so you have kind of, if you like, symbols or abstract, I mean, yeah, depictions showing whether it's going to be the shape or the, I don't know what you call the other thing.
Pattern.
Yeah, the pattern, right. So how did they learn about that in the course of the trials?
Yeah.
And if so, did you look at the dynamics over the trials? That would be interesting to see, you know, whether they, like how fast they learn it and whether they adapt the, like, their expectation of informativeness.
I actually have a slide on that. So we see that looking time increases by trial, and I think this would address what you're talking about. So this is one possibility that suggests, or one thing that suggests that they actually got better over time. So they got the informative cue over time. But another way to look at it, which is what we're going to do now, is to see how well they match once an informative cue is presented, whether they actually match the form of the shape that is revealed to them in the informative trial right away with the box that corresponds to this. Thank you.
Hi, thank you for the talk. I was wondering, for the first paradigm you used with the preschoolers, the information cards had, like, for each of the categories, 3 items, right? If I understand that correctly.
Yeah.
And could it be that the preschoolers are basically simply associating that when there are different items on the information card, then that's the cue for the sticker, for the present?
Thank you. That's a great question. I'm going to just, so what you're saying is interesting, because if I understand you correctly, then it could be that preschoolers kind of use a heuristic of simply going for, oh, where is the card where different things happen, right?
Exactly.
Is that what you mean? Yes. So this is a possibility that we cannot fully rule out with the data that I have presented. But I think one way that we try to account for this is the counterbalancing, because saliency can come in different ways. And one of the most salient things would be the color, right? And even in the color condition or in other conditions, children are able to select the correct information card. But we are currently running a follow-up study to rule out this possibility, where we, so imagine seeing the 3 shapes, but then also seeing 3 different icons and seeing 3 different colors, even though the boxes don't have different colors and there are no different icons.
Yeah, all right, thank
but
you.
It's an interesting question. Thank you so much.
So just a quick question about the eye tracking study. Since the cue before the reward was always based on the shape and not the pattern, at least in the stimuli that you showed here. So even in the pattern case, the shape lights up green and the target color change, right?
So there is always one target that is lighting up,
Right, but it's always the shape and not the pattern on the target that lights up. That's the question.
Oh, yeah, that's true.
Okay, so the question is basically, do you see an overall greater effect for the shape cue because of that? Because the shape is given primacy because of that pre-reward cueing.
That is a great question, and I unfortunately haven't looked at this, but it's what we're going to do. Yeah, is there a difference between whether the pattern or the shape is the informative condition? Yeah, thank you so much. That's a good suggestion.
Okay, let's thank our speaker.
Thank you very much.